Good morning, all of you. So, today's class we are going to study about high-speed QRS detection algorithm. So, we can also call it as Pan-Tompkins algorithm. So, here the procedure is first of all the input EMG, that is ECG signal. It should be band pass filtered. So, why? To remove any low frequency drift which is present in the signal, or to remove any high frequency noise which is present in the signal, we have to use the band pass filter. Then, after filtering out using the band pass filter, the ECG signal is differentiated. We'll be applying the that is first order differentiator or second order differentiator to differentiate the signal. Then the ECG signal is squared. So why we are squaring the signal? Because to remove any negative peaks is present. Because our ultimate aim is to detect the QRS complex from the ECG signal. So that's why the ECG signal is squared to remove any negative peaks present in the signal. After that, to the ECG signal, we will be applying a moving window integrator. So that is applied over the signal, and then finally thresholding is applied to detect the QRS complex from the ECG signal. So in this procedure, this is the block diagram which illustrates that. So first of all, the ECG signal, it is given to a low pass filter to remove any drift present in the signal. Then it is passed to the high pass filter to remove any high frequency noise. Then the output signal is called Y of n, which is first differentiated with ones with respect to time period. Then it is squared. Then the squared signal it's into a moving window integrator. The window size is 32. So the equation it is given by 1 by 32 of summation n equal to 1 to 32. So throughout the signal we will be placing the window and averaging the signal. This time averaging the signal. So this is the waveform which illustrates the sampling of this ECG signal, in which the signals are sampled at equally spaced interval. So you can able to see the sampling rate they have applied is 200 samples per second. And then if you see in the as a first step, there are so many interference signals are there. So that like muzzle noise, power line in frequency, baseline wandering effect, T wave noise. So these interference signals are eliminated by using the low pass filter as well as high pass filter. So if you see the low pass filter, its digital transfer function is given by 1 minus z power minus 6 divided by 1 minus z inverse. And if you want to get the transfer function of high pass filter, it is simply z power minus 16 minus 1 by 32 of 1 minus z power minus 32 divided by 1 minus z inverse. That means you get the high pass filter response is the original signal response minus the low pass filter version, you can get the high pass filter. So here z power minus 16 represents, we are subtracting the original signal. That is, we are dividing the output of the low pass filter by its DC gain and then subtracting from the original signal delayed by 16 time periods units. So next is we have to attenuate the T wave by passing the waveform to the high pass filter and enhance the Q wave and S wave. Then the high pass filter signal is passed to a differentiator to differentiate the signal. So this is the differentiator signal which is given by 0.1 of 2 plus Z inverse plus Z power minus 3 minus 2 Z power minus 4. So how this we are getting this difference equation is we implementing using a difference equation. So this is the difference equation. It is given by 2 into yn of nt plus y of nt minus t minus y of nt minus 3t minus 2 into y of nt minus 4t divided by 8. So in this, when you apply the Z transform and then take the transfer function of it, so we will be getting this particular equation. Then the next step is we have to square that signal so that the negative points will get eliminated. Then it is passed to a moving window integrator. So in the moving window integrator, window will be moved over the signal and it is get averaged. So it is given by the mathematical expression like that. It is denoted by Z1 of nt. This is the mathematical expression for moving window integration. Then finally thresholding is applied. There are two levels of threshold is there, threshold 1 and threshold 2. Threshold 1 is calculated by the formula NPKI. What is meant by NPKI is the running estimate of a noise peak plus 0.25 into SPKI is the running estimate of a signal peak. So for to obtain the threshold 1, the running estimate of noise peak plus 0.25 into running estimate of signal peak minus noise peak will give you the threshold value 1. To get the threshold value 2, we have to multiply threshold value 1 with 0.5. Next, what is this running estimate of signal peak? Again, it is having the formula. To calculate the running estimate of a new signal peak, we have the formula 0.125 peak I plus 0.875 SPK of old. And to determine the running estimate of the noise peak, we have the formula 0.125 peak I plus 0.875 into NPK of old. So this is the threshold equation, and if you see, this is the waveform which shows the low pass filtered ECG signal, and this is the block diagram which illustrating the high pass filter. It is obtained by subtracting the low pass filter minus the original filter, which is given by z power minus 16 minus the low pass filter transfer function. And this is the band pass filtered ECG waveform. Then this waveform represent after band pass filtering and differentiation. Then this is the squared waveform, so that the negative peaks are getting eliminated. And after squared waveform, you have to apply moving window integrator. You will be getting a shape of a QRS complex like that. Then you are applying two levels of threshold to detect the QRS complex from the ECG signal. Now when you see, the first one is an unfiltered ECG signal, second one it is a band pass filtered signal, then the third one is output after band pass filtering, differentiation and squaring process, so that you can able to see only the positive peaks. The negative peaks are eliminated after squaring. Then the final one is after it is applied to a moving in the average output and followed by the thresholding, you are getting the QRS complex signal like this. Thank you.